Okay, here we're given a function, a polynomial function of degree 3. We're given that 5 is a 0. Which we also know means that if a factor of this polynomial is x minus 5. So what they're asking for here is to find the remaining zeros. And I know there are going to be 2 of them because this is of degree 3, so I'm expecting 2 more zeros. So the best way for me to start is to use synthetic division, a little crooked, and I'm going to put my value, my value of k up here, and I'm going to put up at the top here the coefficients of this polynomial, making sure that I'm not missing any terms. 3, 2, 1, 0. There we go. So 1, -9, 40, and -100. And because they told me already that 5 is a 0, I'm expecting that my remainder is going to be 0. So as usual, I drop the 1. I multiply the 1 times the 5 to get 5 and put it here. And I add to get -4. I multiply -4 times 5 to get -20. And I add to get 20. And then I multiply 20 by 5 to get 100. And I add to get my 0, which I expected. So this tells me what we already knew, that x minus 5 is a factor. And the synthetic division leaves me also with the coefficients of the remaining factor, which is going to be x squared minus 4x plus 20. And so all we have to do then is factor this second degree polynomial here. And we can do it in a number of ways. One way to do it is to try to find 2 numbers that multiply to give us 20 and add up to give us -4. And I'm not seeing what that would be here. It's nothing obvious and simple to me. So because if I look at 20, and I know they have to multiply to give me a positive number and add up to give me a negative number, that means there has to be 2 negative numbers. And the only possibilities here are -1 times -20, -2 times -10, -4 times -5. And none of those added together are going to give me -4. So I have to go about another way. One way to do this is to use the quadratic formula and figure out what the roots are here. So we have -b, and our b here is -4, so -4 is 4, plus or minus the square root of b squared, which is -4 squared, or 16, minus 4 times a times c, 4 times 1 times c, which is 20. So 4 times 1 is 4, 4 times 20 is 80, over 2a, so 2 times 1 is 2. Okay, so we have 4 plus or minus the square root of 16 minus 80 is going to be 64, negative 64 over 2. And this clearly is going to leave us with 2 complex numbers. So I'm going to change this to 4 plus or minus. Now, when we see square root of a negative number, we pull out an I. So we're left with square root of 64 I over 2. And then we have 4 plus or minus the square root of 64, of course, is 8. So 4 plus or minus 8i over 2. And simplifying this into the proper form for a complex number, 2 complex numbers, is 4 over 2, which is 2, plus or minus 8i over 2, which is 4i. So 2 plus or minus 4i are my 2 other roots. So finally, I would say, and that's actually the answer to the question. They're asking you what are the remaining roots. So I'm going to continue, and I'm just going to factor it. And say that we have x minus 5 times x minus the first root, which is 2 plus 4i, times the last factor, x minus 2 minus 4i. And again, the question here was find the remaining zeros. That was the problem. So those are the 2 remaining zeros, 2 plus 4i and 2 minus 4i. And that's it.